AGI is the modern day ghost story, and that as human-like as large language models are and image generators are in a sense, there's a big difference between what they do and what humans can do, and we're not nearly, it's not just that we're not close, it's that I think it's a mistake to consider what we're seeing now as a concrete step towards AGI.
Eric Siegel, it's great to have you on the show.
Great to be here, Adele. Thanks for having me.
Thanks so much for coming on. So it's been 4 years since VentureBeat released this widely cited yet hard to corroborate article describing how 87% of data science projects never make it to production. A big focus of yours the past few years is really deep diving into how organizations can make the most of their machine learning investments. And your most recent book, which we'll discuss in depth today, the AI Playbook, focuses on this exact problem. So maybe to set the stage, how has the state of machine learning deployment evolved over the past few years since that article was released? And why is it still such a big problem today?
Well, I think a few years, may be a relatively short timeline in how long projects have been out there and also failing to deploy. I don't think much has changed, but what has changed the last few years is we have a lot more concrete stats. I was involved with some research projects, in part as a one-year analytics professorship at UVA Darden. And I did that in conjunction with the Rexer Analytics data science survey. And we found in the results that among new capability initiatives, only 22% of data scientists say their projects usually succeed to deploy. More generally, when you go across all projects, including just refreshing a model, it's a bit better, but in that case, 32% say their models usually deploy. So we don't have a direct match there, but we're definitely seeing that. I think you're potentially going to link to that particular research result, and we're linking to other ones. So there's a bunch of stats. IBM recently came out with stats with industry research saying that there's no returns. That is to say, the average return of an AI project is lower than the cost of capitals on average. Now, of course, there's many glowing successes, but there's a dismal track record that stands much to improve, and methinks it's an organizational issue more than a technical one.
So you mentioned here the technical issue. I think a lot of the conventional wisdom, when it comes to why these machine learning projects never make it to deployment or drive ROI, the conventional wisdom says that, it's the lack of ML ops or operationalization capabilities within many data teams that has been the main culprit of why this is the case. In many ways, the birth of ML ops as a subfield of machine learning is a response to this dismal track record that you describe. But in your book, you go beyond that and you discuss how, the current paradigm by which we approach machine learning projects, and you hint at that as an organizational issue, is in dire need of change. So maybe walk us through that current paradigm at the moment and why is it lacking?
Right. I think that another technical approach, ML ops is necessary but not sufficient. And hinging on that as the solution to this deployment problem is just a continuation of our overfixation on the core technology and the technology in general. This is an organizational issue, and what it needs is a standardized practice, which I offer in my new book, that everyone needs to get on the same page, both in the data science, technical, and on the business side, the stakeholders across the organization, and follow a paradigm, a procedure, a discipline, a playbook, right, that everybody understands so that they can participate and collaborate in detail from end to end, from the inception of the project to its deployment. That's where we're going to make a difference. And along the way, most certainly there'll be ML ops techniques and tools that are adopted to that end. But the dog that wags the tail has got to be an organizational. It's a business project meant to change business operations by way of using machine learning, rather than being a machine learning project that, as a side effect, helps the business.
And maybe why do you think that organizations, despite this current track record, that is, pretty poor from what we've seen from the stats, still operate in this failure mode where they approach machine learning projects as, a purely technical project that has a side effect of helping the business rather than the opposite?
Because we haven't had enough conversations like this. Maybe this will be the one that brings us over the edge. It's this fetishization of the core technology. Machine learning is awesome. That's why I got into it originally. The ability to learn from data, to find generalizations that hold over new situations, to actually learn from data in that respect. It's really awesome. It's very exciting. It's quote unquote the most advanced cutting edge of technology. So decision makers, rest assured, they're using the best technology. And with all the hype now, especially because it's multiplied so much by Gen AI hype, these failures, when a project actually doesn't get to deployment and therefore, of course, offers no returns, are swept under the rug. And they're swept under the rug adeptly. People protect themselves by doing that. Organizations protect their reputation, and it's only natural. So there's definitely zeitgeist building, more and more of these reports about the track record and concern about that, executive awareness. It's definitely changing. Running on the sort of fumes of hype and excitement about the technology rather than its actual deployment isn't sustainable. And it's going to come to a point of crisis, unless people sort of get out ahead of it. And that's what we're trying to do and that's what I'm doing and what you're helping me do, talk about this and trying to bring this idea of a standard business paradigm. So it's sort of like right now, the world's more excited about the rocket science than the launch of the rocket. It's kind of like, hey, this rocket science is so cool. We could launch the rocket maybe next week, maybe next year, but it doesn't really matter. The science is so cool, right? And some rocket scientists may actually feel that way, but you know what I mean.
Yeah, I completely agree. And, there's someone that I worked with in the past that called this resume-driven development, right? Where it's not actually focused on driving value. It's actually focused on, being able to showcase the shiny toy that you're working with and you're working on as an organization. And you mentioned, this business paradigm and leading with the business, right? As an organization. You mentioned this in your book. You call this, aptly called BizML, right? What this paradigm tries to do is that it attempts to bridge the gap between the business and the data team, right? So before we go into BizML, maybe walk us through what this gap looks like, why does it exist, and how it manifests within organizations.
So the gap is that both sides are kind of pointing to the other towards sort of taking ownership of running an organizational practice that will successfully lead to the actual deployment, capture value. Machine learning is a technology that's great at generating value. What we want to do is actually capture it by way of deployment successfully and carefully in a way that meets the business strategy and needs. My message is that to bridge this gap, the business stakeholders, the business professionals, your client as a data scientist needs to ramp up on at least some semi-technical knowledge. And that is what's predicted, what's done about it, and how well it's predicted. So you need to this isn't about the core rocket science, not about the machine learning algorithm or even what's under the hood inside a model itself. Although there's certainly no reason to get us down. When I drive a car, I have a general sense of how internal combustion works, but I don't really need to get into the nitty gritty. And I've never changed a spark plug. Excuse me. Let's start that again. A spark plug. To be honest, I've actually never done that. But to drive a car, I need a lot of expertise in understanding momentum and friction and how to steer and the rules of the road and expectations of other drivers and my expectation of their behavior. And theirs of mine. So the same applies to running a machine learning project. A operations improvement project really is what we should reframe it as, that uses machine learning. And by getting the business stakeholders ramped up on that kind of semi-technical knowledge, it's definitely less difficult than high school algebra, a heck of a lot more interesting and pertinent. It's about running your large-scale operations more effectively. What's predicted, how well, and what's done about it. If we get them up to speed on those basics, then they can speak the same language and participate and deeply collaborate from end to end, backward planning for deployment from the inception of the project. And by having them involved, you're not going to get to, so the syndrome of what happens now is that towards the end of the project, hey, we're ready for deployment, or we're almost ready, or this model might be ready. And then the stakeholder often gets cold feet. They don't understand the metrics. They understand, hey, a model predicts better than guessing. And that's probably good enough. Doesn't have to be a magic crystal ball. Better than guessing is generally sufficient to drive tremendous impact on the bottom line of improving the numbers games that we play with all these large scale operations in marketing and fraud detection and credit scoring and online ads and all this. But they don't have a concrete sense of the math. And that's the second of those three. What's predicted, how well, what's done about the metric. So by ramping them up to that point of that certain kind of data literacy, then they can participate. And they're not going to get cold feet at the end. They're going to have a concrete sense from the beginning of the project and from its green lighting of what exactly deployment will entail.
So we talk about data literacy quite a lot on Data Frame. So I'm excited to unpack, your views on that. But maybe first, let's take a step back and look at the BizML framework in a bit more depth. You outlined the BizML framework in quite a few steps throughout the book. So maybe walk us through that framework in a bit more detail and what those different steps look like.
Yeah, sure. So BizML, we break it into 6 steps, and the first 3 correspond to those 3 fundamentals: what's predicted, how well, what's done about it, but not in those order. So they're pre-production, you're establishing those. And the other 3 are the same thing you do with any ML project. Everybody who's involved with ML knows this: prep the data, train the model, and deploy. Obviously, you need to monitor moving forward, but we're framing it just trying to get to deployment. We talk about that later in the book, but BizML, as I'm formalizing, is those 6 steps. You could formalize the project as 5 steps or as 7 steps. People, at least senior data scientists, are familiar with the idea that you need to conceive of it into that kind of organizational process, but there's no standard that's generally known, especially to business side practitioners. In fact, your stakeholders, your client, the business side, generally don't even know that machine learning projects really require a specialized kind of business paradigm. So what I'm trying to do here is send 2 messages: ramp them up on those 3 semi-technical concepts: what's predicted, how well, and what's done about it, and the need for a paradigm. Let's give it a nice buzzword, as you said, BizML, right? So that's actually the domain for my for my book, bizml.com. So I put in several hours, people, picking out just the right 5 letters for what I think could be an awesome buzzword just to help evangelize this whole point. But let's all get on the same page for the need for a standard business side paradigm or playbook. Let's agree to how to break it down to 6 steps or something like that. And the need for that collaboration and the ramp up on the business side. So that's my message. And I think that that's the antidote. I think that's where we're going to get a lot more traction, not just in how excited and hyped up everyone is about machine learning, but in actually getting value-driven, deployment-oriented projects and greatly improve that track record.
Okay. And, you talk about this collaboration element here. I want to zero in on that. When I look at data teams in general, when I speak to data leaders, I'm much more involved with the data leadership aspect. And what I get a sense from when they speak about data science and machine learning projects is that there seems to be an expectation that both parties have between business stakeholders and data scientists and data teams. They expect the other teams to own the main drivers of the ROI of a machine learning project, right? Data scientists see themselves as the architects of a technical solution to a business problem that the business stakeholders should own. And business owners see themselves as handing off, to a certain extent, that the problem to the data scientist and the machine learning engineer. So maybe how does ownership and collaboration evolve under the BizML paradigm? How should data teams and business stakeholders evolve their collaboration and their approach accordingly?
That's a great question, and it's the pertinent question. I'm agnostic about it, and I've framed BizML in a way that it can go either way, or some combination, or a new role, or a new responsibility of the chief data officer, whatever it is. The point is that somebody's got to take it on, and if the organization agrees that, hey, we need to follow a specialized business paradigm so that we actually plan and collaborate accordingly so we can get this thing deployed, not just the number crunching, not just a model that looks pretty hanging on the wall. Then if in order to execute on this business paradigm, obviously somebody's going to need to lead it, take responsibility. You're very much right the way you put it, that both sides tend to point to the other as a responsibility. And in that way, the hose and the faucet are failing to connect, right? Data scientists think, well, that's all kind of managerial stuff, and my job's just to make a model. Its value is self-evident. It's not my responsibility to get it deployed. Of course, the organization will deploy it unless they're nuts. Whereas at the same time, business professionals say, oh, I don't need to get into those details. I delegate all that to data scientists. So, I don't need to look under the hood of the car in order to learn to drive it. But as I mentioned, no, they do. The organization, business leaders need to learn semi-technical, not the core rocket science, but how well the rocket science works, how it's predictive outputs, the probabilities output by model, will specifically integrate, will actually drive individual organizational decisions. That level of detail. And once you start talking to a business stakeholder, well, this is what I mean by semi-technical. You don't need to be changing spark plugs, but you do need to be getting a sense concretely of how this is going to deliver value and how much value it's going to deliver. It's not that crazy. And they're like, oh, okay, I don't have to be a rocket scientist. I don't have to actually crunch the data myself, but there is something kind of semi-technical. And from the data scientist's perspective, what I'm referring to is semi-technical. Again, what's predicted, how well, and what's done about it, isn't technical at all. And from the business person's perspective, it's often extremely technical. So there's this long continuum between the two sides that we need to get to connect. So let's agree to the sort of midpoint that everyone speaks that same language. It's a sort of a stretch for both sides, but otherwise we're just going to continue the same track record.
Yeah, I agree there. And then when let's maybe take an example in a lot of ways. We talk about here creating that collaboration and, someone owning the agenda on both sides, right? Let's say we're starting to scope out a machine learning project. Who should be in the room? How do you get started? How do you make sure that, you start on the right foot when it comes to, enabling that BizML paradigm to succeed in your next machine learning project?
Yeah, it's a great question. Like, who's in the room when you're conceiving of the project, when you're preliminarily authorizing it, eventually really greenlighting it, and investing more and more resources incrementally, all those early meetings, and who's the driving force? So the answer to those two questions are very much overlap as far as who's in the room, right? Often it's going to be a data scientist, one that's senior enough or thoughtful enough to realize they're not just there to crunch numbers, but to provide value to the organization. And they need to take the bull by the horns in this respect. They're the ones already familiar with what it means for a model to predict, and then they're at least conceptually familiar with what it means to take predictions and use them to drive operational decisions, who to contact and which transaction to audit or whatever it is. Or it could be, the same question corresponds to, does this happen from the top down or bottom up, right? Is it somebody who's on the staff who's really doing the number crunching, or is it literally the CEO, right? It could come from either side, it could come from both, but it's got to come in a way that's very specific and concrete in terms of the value proposition, right? Which is, the use case, which is two of those three things: what's predicted and what's done about it. Instead of just, hey, what's our AI strategy, or let's use machine learning somehow. It's got to start with that level of detail, but then get a lot more detailed, in not only from the data scientist side, but from the business side. So again, I'm kind of agnostic. It really depends on the organization, and it varies greatly from project to project and organization to organization. But however it sort of starts to evolve and emerge, right? It's got to become deeply collaborative. One side's got to pull the other side in.
Maybe when you talk about collaborative here, I think, a big obstacle data teams and business teams have when it comes to collaboration together is defining successful metrics for a machine learning project. And what I mean by successful metric is not accuracy or precision or recall of the algorithms and their performance, but the business impact, quantifying the impact of a incremental improvement in the performance of an algorithm from the business's perspective, right? So maybe what is your advice for whoever is in the room here when quantifying the business impact of a machine learning project?
Yeah, quantification is absolutely key. It's the second of that list of three that I keep repeating. What's predicted, how well, and what's done about it. What are the metrics? And yeah, you're totally right. The main metrics that we focus on as data scientists are not the most pertinent metrics, and they're sometimes necessary, but never complete. You need to go to business metrics. Profit, number of customers saved, number of lives saved, number of dollars saved. Things that any stakeholder can understand, things that are pertinent to the business. And it turns out, if we haven't noticed, that there's a really big disconnect between the technical metrics like precision recall, and even accuracy is just a technical metric that doesn't differentiate between false positive and false negative costs. It's usually impertinent and often very misleading. But anyway, all those and maybe the most egregious is area under the curve, area under the receiver operating characteristic curve, which has the same problem, for example, as accuracy, of not differentiating between the costs of those two different kinds of errors. But in any case, let's move to the business metric. And the relationship between the two is elusive as at best. You don't translate directly from one to the other. You have to measure and forecast how well will this model potentially serve those business metrics like profit and ROI or what have you, or how well has it already when you're monitoring after deployment. Either way, we need to track organizational success. And this is a really key point in bridging that gap. In fact, I've co-founded, this isn't even public yet, but I've co-founded a startup called Gooder AI, to make your AI more gooder, that focuses on measuring the performance of models in business terms. And the trick is, so my experience is that there are tends to be more senior data scientists who have the wherewithal to say, oh, you know what, we do need to kind of calculate profit. We need to make a profit curve or what have you. And when they decide to do that, if and when a data scientist wants to, existing model training tools don't do that for the most part. Right? You have to hack it from scratch in a bespoke manner, often in Excel or in a scripting language or what have you. Then you get a static report. But it turns out when you go to those kind of business metrics, there's a little bit more that you need to do, which is that you need to parameterize in terms of false positive and false negative costs, in terms of the confidence threshold, all the assumptions, the business context. You need to parameterize it in terms of the exact deployment scenario. A model itself isn't worth $1 million. It's only worth $1 million if that turned out to be the metric. Depending on how you actually use it. So you need to parameterize that deployment, those deployment particulars, and have a nice interactive GUI, an interface where you can set it up and evaluate. So that's what we're building. If you go to gooder.ai, you're just going to get to my book right now. But anyone out there, please reach out to me if you're interested in being a beta customer, if you want to have a tool that readily does all of the above and lets you do those business metrics. It's absolutely, I'd say that's the main missing technical component, technical solution in the ecosystem for machine learning that's outstanding when we're talking about getting to business value and ensuring a successful deployment.
Let's switch gears slightly here. When we're talking about the evaluation of the business metric, right? Let's say we defined a business metric and we have our forecast, right? And then we're switching to deployment. I think outside of just operationalization, being able to, embed the machine learning system into, a broader technical system within the organization is how do you also embed it within a business process, right? I think that's a big challenge as well organizations have. So, how early in the conversation should we be thinking about the way by which a machine learning system will be embedded in a business process and how it will be leveraged in daily operations? Maybe walk me through that particular issue.
Yeah, I mean, I think you almost answered your own, like the question itself is you're already making a great point. Yes, this needs to be conceived of from the inception of the project, because the whole point is to improve operations. The point of the project is not to use cool technology. I might be working as a data scientist because I love cool technology And indeed, I've been in the field 30 years, and definitely that's why I got into it in the first place myself. And I think that's the same for a lot of data scientists. But we're not running this project. The organization's not running the project because it's cool technology. It's running the project to improve operations. So if you're planning a project that improves operations, you also need to be able to plan to measure and track how well those operations have improved in business terms moving forward. And I think we'd hopefully like a little bit more than that, not only the sense of how well the model's performing, both technically and in terms of the business metrics, but also continuing to enable an interactive trial and error of what if scenarios. What if we had, over the last few months, what if we had changed the way this model has been deployed, changed the confidence threshold, changed some of the assumptions, the integration? What would that have done? Because we're going to get ground truth later, right? So before deployment, you've got the test set. That's already that's not just the best practice, it's the only practice. You've got the held aside test set. That's what you're evaluating on. You already have the labels, or time is told who clicked, bought, lied, or died, who canceled, right? So we have those dependent variable values. And then you're going to get them eventually after deployment, depending on the use case. You have to wait a while, which of these transactions turned out to be fraud. But then you have them just the same as pre-deployment. And you're once again retrospectively evaluating the performance of a model. And once again, do the same thing. Try some what ifs. What if we had done this differently? Well, then maybe we should change that for the next quarter. So yes, I think that's a great point that you sort of served up for me, right? If this was volleyball, don't you love it when you're playing volleyball and somebody and you're right? So that was great.
Yeah, I appreciate that. I'm here to provide you layups, Eric. Yeah. So maybe let's, you talked about, we talked about quite a bit on the theoretical aspect of BizML. I want to anchor our discussion in a bit of a real world example. And you provide a great example from UPS in the book. An example of how they've leveraged machine learning to on a route optimization use case. Walk us through that case study in detail, and maybe walk us through the pitfalls they encountered at the beginning, how they switch around, and what you hope other data teams learn from this particular use case.
Yeah, sure. So the main technology that I'm talking about at UPS, they internally call it package flow technology. So it's predicting tomorrow's deliveries and next week's deliveries, et cetera. But it's most active when you're really just talking about tomorrow's deliveries in order to optimize the planning of the delivery truck. So it's literally the last mile or the last several miles from the shipping center onto the trucks. How do you delegate all those packages to trucks and plan accordingly? And they improve that greatly by predicting, because there's a lot of uncertainty. They have a bunch of packages that have already come to the shipping center, but a bunch more that are still coming. And there's a lot of reasons that there's uncertainty about when they'll arrive and whether they're for delivery tomorrow or whether they even exist at all. So it turns out that had a great impact. In fact, in combination with not only prescribing which packages go together in which truck, but then also prescribing the driving routes, which some number of years ago was also pretty innovative, rather than the expertise of the driver. Together, that provides UPS an ongoing savings of 185 million miles of driving a year, $350 million, 8 million gallons of fuel, and 185,000 metric tons of emissions saved every year in the US. So I bookended my book, the AI Playbook, about BizML with that UPS case study, because I talk about two places where there were organizational challenges. The early one was getting the green light on the project in the first place, and there you're trying to convince an executive. And then later, we're trying to convince the staff members working on the loading dock to pay heed to these prescribed behaviors of which package goes into which truck and change their behavior. And so in a sense, you need full stack organizational buy-in. You need to get people at all. I mean, we're changing operations. So this is just change management 101, right? Change management's hard. It's a discipline. There's a lot of ways to do it. And I go through some of that in the book of the cajoling and the aligning incentives and the right sort of short-term metrics and scorecards and all that kind of stuff. But the bigger point is that, look, you need to do change management. And that fundamental is actually overlooked so often because people aren't conceiving this as an operations change project. They're conceiving it as a machine learning project. No, we need to reframe it as an organizational operations improvement project that uses machine learning. But the reason we don't call it that, the reason we call it a machine learning project is because it sounds cooler.
I agree. And you mentioned here change management, and a big aspect of change management is skills transformation, and this touches upon your early points on the importance for business stakeholders to develop a semi-technical understanding of what are we predicting, what's being predicted, and how do we measure. So I think it's important in this BizML framework for, and you mentioned this quite a few times, data teams and business teams to have a common data language. Um, so we talked about, the ability of data teams to translate machine learning projects to business impact, but business teams should be able also to understand, to a suitable technical degree, as you mentioned, what goes into a machine learning project and how do we expect that machine learning project to impact my area of the business. So maybe walk us through, in your view, the importance of upskilling and reskilling here, and what do you see as the basis of this common data language?
Yeah, so it's that same three. You don't mind if I say the list of three again, do you? What's predicted, how well, and what's done about it? What's predicted, how well? So what's predicted and what's done about it? That's the use case, right? And that's why machine learning is so widely applicable. Any new potential use case is simply you come up with a viable pair. What's the dependent variable? What's predicted by the model, and then how are you integrating in actual deployment those probabilities output by the model? What process are you improving? What operation? What large scale number of decisions, and exactly in what way? So getting into those details, and then the second of the three is how well, and that's the metrics part. So this semi-technical understanding actually includes. So there's no standardized curriculum. That list of three and a course on it or a book on it should be standard for all MBA students, for example. It doesn't require more than high school math. It's the metrics part of it is only arithmetic, but it's very particular arithmetic. And it's not the kind that people are generally aware of, at least outside of data science. Even data scientists haven't been trained to spend much time on going to those business metrics. And I should mention that the difference between technical and business metrics is technical metrics only tell you the relative performance. So how much better than a baseline, like random guessing. Important, interesting, but it's all we're trained to focus on as data scientists. So then we feel satisfied based on the area under the curve or what have you, but we shouldn't be satisfied. So that move to accuracy and such, and understanding the difference in the relationship between technical and business metrics. So, but it turns out that this sort of semi-technical that I'm not just espousing, I'm strongly espousing that really business stakeholders need to ramp up on universally. Some of that is also not common knowledge, even among senior data scientists. So, for example, everything I'm saying about metrics, like let's break through this. Let's look at really what the problem is with AUC. Let's look at the limitations, precision recall, and what it would take and what it means to transition to business metrics. Also, part of the semi-technical, the first of those three, what's predicted, I don't just mean let's predict customer churn who's going to cancel. It's got to be much more specific. Which customers who've been around for at least a year are going to decrease their spend by 80% and not increase it accordingly in another channel within the next time window of 3.5 months. All of those details, and it might be 3 times as long a run-on sentence. It's a yes/no question for most of these binary prediction goals. That's the definition of the dependent variable. Don't call it a dependent variable when you're talking to a business stakeholder. Call it the model output. In my book, I call it model output because this is relevant to the business. It's not an arcane technical thing. Exactly, precisely what's predicted, and getting into all the gory details, which all are all those details are relevant from the business perspective when you think about how exactly those predictions, they're defining what are you predicting, and then you also have to define how those predictions are going to be used. Those two go together, and in all that gory detail, you need to get the business stakeholders. But data scientists also haven't been ramped up on that business exercise of fleshing out all the details of defining the dependent variable. Let's call it the output variable. Data prep, that's another one, right? If the last three main production steps and the last of six that I call BizML are prep the data, train the model, and deploy it, well, the data prep is generally skipped over. Data scientists and all their excitement about the core technology, and I'm not immune to this. If you go back in time to earlier in my career, it's let's jump right to the modeling. Who cares about the data prep? But you're skipping over all these pre-production phases that decide what's going to be done, what's going to actually, how deployment's going to be entailed, which in turn informs the detailed specific definition of the dependent variable, which then is manifested by the data prep, not by the modeling part. You don't adjust the modeling according to the dependent variable's definition. No, that is manifested by way of how you prep the data. And getting into all the ins and outs of data prep, it's not the fun rocket science, but it's an absolute technical necessity. And it's generally not covered in a very forceful way in data science curriculum. So again, my point here is that a lot of the stuff that's kind of semi-technical and that it's important to get the concepts across to business stakeholders and get them upskilled is also kind of new to data scientists because it's not part of the standard curriculum.
Yeah, that's great. And there's something I'm trying to, when you're walking through these different skill sets and these different kind of concepts and semi-technical concepts, that even data scientists need to know about. It seems that there are, generally applicable concepts that, anyone can get into, but there's also organizational specific concepts. You mentioned like that customer churn metric, right? Like customer churn in telecom is very different from customer churn in Netflix, is very different from different organizations, right? Maybe walk us through examples of, organizations who've been able to nail that, internal education internally on like really specific data use cases within the organization and how you've seen that play out.
Yeah, well, that's a great question. And there, as I sort of briefly maybe mentioned earlier, maybe not emphatically enough, machine learning is not a failed discipline overall. There's lots of successes, even if they're in the minority. A small, whether it's 15 or 25%, depending on how you count and measure the number of projects that actually succeed in land deployments, that percentage of a lot of projects is a lot of success. I think as we all know, there's lots of organizations that are really at the forefront of this, big, not the least of which is big tech. So I spoke to a manager at Amazon, and they have, unfortunately, there's not general solutions to this that's available off the shelf yet. And as I mentioned, we're working on this. But Amazon has its own particular solution of mapping performance of models to exact business metrics that they have in mind. And so you're really directly measuring it. And it also kind of makes sense that big tech would tend to have a more technical mindset across the organization, including the business leaders and managers and executives. That would tend to be the case there more than like UPS, which is more than 100 years old. And so the change there was a big one. They had to very forcefully push it through, and in the end, successfully. Another case that I cover in the book is FICO, that is very well known for credit scoring, but perhaps a bigger part of their business is fraud detection. And their fraud detection model scores in real time each card transaction for 2/3 of the world and 90% of the US and the UK of all credit cards in real time, because all the banks, or most of the banks, are customers and use. So the exact model for card payment fraud detection is called Falcon. It's delivered by FICO, and then it's the same best model used across all these banks. So even small banks can use the best fraud detection model. That model and the process has been honed so well over so many banks, so they know exactly how they want to predict, define that dependent variable for fraud detection and churn it out. But then it's up to these individual banks to figure out exactly how do I deploy it? Where do I threshold? What's my tolerance for risk of fraud, depending on the size of the transaction, for example. But there's lots of large financial services organizations that are really also at the forefront and have a well-honed process. So what I'm describing here might be rare, but certainly not unheard of. It's a matter of making it pervasive and getting the rest of the world in a position where they can catch up with those at the forefront and share in the upside, right? Because right now, um, what everyone's sharing in it is the hype and the excitement, and it's not yet being matched, right? But there's no reason it shouldn't be. The core technology is solid. It's a matter of coming down to earth, getting concrete, and working end to end in a unified manner that's collaborative with the business side. Somebody who's in charge of the operations that are going to be improved by a model, that in a sense is the stakeholder. They're the ones who own the large scale operation that needs to be improved. They need to get involved in the nitty gritty and they need to think quantitatively. If they're not willing to think quantitatively, then they shouldn't be in charge of a large scale operation, right? But again, it's not the rocket science part. It's just very particular arithmetic to understand those metrics.
You mentioned the last thing, one of the last things you mentioned here is the not coming to the hype, right? And coming back to earth. When we're talking about hype, I think I'd be remiss not to talk about the generative AI elephant in the room as we talk about BizML. If we take a step back and take a bird's eye view, I think generative AI is going through the early machine learning 2010s moment where, self-driving cars are starting to becoming a bit more of a reality. We've seen like more awe-inspiring results. And I think that led to this gold rush approach of, fetishizing the science rather than the solutions. Um, are you worried generative AI is going through the same motion as machine learning? And what do you think are the dangers here of overhyping generative AI?
I think that's a great point to make that parallel between the sort of cycle that we're still suffering from with, you might call it predictive AI rather than generative AI. What same as what was how has always been called predictive analytics. Either way, it's machine learning enterprise use cases that improve large scale operations. So yes, we're still suffering, and that's what we've been talking about today. And the suffering around the generative AI hype is coming. And I think very much there is a parallel. And I would say that the generative AI hype is worse. So we're setting ourselves up for a more difficult shift and downfall. I don't know when the next AI winner is coming. It could easily be 5 or 8 years from now. It's definitely coming, but maybe more of just sort of a reckoning, or certain reckonings are coming. The thing is that generative AI is amazing. And I was in a natural language processing research group for 6 years during my Ph.D. before I was a professor at Columbia. I did them both at Columbia University. Um, and I never thought I'd see what large language models can do in my lifetime. But as excited and amazed as I am by it, I'd say the world is about 10 times more amazed. And then, of course, in my opinion, 10 times too much amazed, and maybe overvalued this by the same proportion, maybe more. And what it comes down to is the AGI hype. And I think that AGI is the modern day ghost story. And that as human-like as large language models are, and image generators are in a sense, um, there's a big difference between what they do and what humans can do. And we're not nearly, it's not just that we're not close, it's that I think it's a mistake to consider what we're seeing now as a concrete step towards AGI. And I think AGI is sort of the often unspoken, but the undercurrent of the hype. It's the sense of, hey, anything's possible, and we're definitely headed in that direction. And that's what's being promulgated a lot by these large language model companies to their own financial benefit. But I don't think that's good for anybody, including them. It's going to hurt.
It's interesting what you mentioned here. I agree with you. And you mentioned this concept of AGI. In a lot of ways, the foundation model companies don't do themselves favors when they say that they're developing AGI. And when you take, we mentioned this parallel and we take the BizML paradigm as potentially a remedy to the underlying problems with machine learning hype or traditional machine learning hype. Do you imagine a similar playbook will be needed to succeed with generative AI, or um, do you think we'll be able uh, to leverage existing playbooks like the BizML playbooks to speed up time to value with generative AI?
No, that's a great question. And indeed, BizML as formulated is largely specific to predictive use cases, established use cases, the ones that improve large scale operations. Although generative, broadly speaking, it's very much the same kind of thing. You need to, from the inception, exactly what operations or individual tasks by human are going to be changed in what way. But I think the answer to your question is that it won't just be a one. For generative, it can't be the same kind of one size fits all framework, at least fully spanning, because there's so many different ways we could be using a large language model or image generator. But for the most part, let's be clear. Those models help people. They don't automate. In fact, even though they're more human-like, they ironically actually lend less potential autonomy because you need to supervise every output. You need to proofread everything it writes. You can't trust it. Whereas the kinds of things you're doing with predictive AI, all the large scale operations we do as business, they're wrong. They're wrong often, or even most of the time for mass marketing or whatever the operation is. Now we're improving it so it's less. It's wrong less often. It's a significant improvement. It can be multiplier on the return on investment or the bottom line of the project. But there's that kind of leniency. There's that kind of forgiveness to the nature of those projects. Therefore, it can be autonomous. It automatically decides on the fly instantly whether to authorize your credit card charge based on a fraud detection model. That's autonomy, for example. You've got a million prospects and you're deciding exactly which ones to include in your next direct mail. Same thing. You've autonomously made those decisions. Even if you're physically licking each stamp manually, there's still autonomy in there. But the same thing doesn't tend to apply for generative AI applications.
That's really great insight, Eric. So we are recording this on December 8th, and I think this episode is going to release early February, first week of February. Maybe what are trends that you see for AI in 2024?
Well, I think that there's going to be this strange rise of both disillusionment and hype. I mean, the AGI hype is not going to go anywhere, going to go away very soon, although by the time you're hearing this, I've hopefully published a new article on that, in which case potentially you can include the link. So the reason I think that the hype's going to fade more slowly than might be ideal is because generative AI is capable. First of all, it's the best damn demo ever of anything ever, period. I mean, I'm astounded by it. If I, didn't have so many job responsibilities and family responsibilities, all I would do is sit around playing with a language model. I think it's incredible. It's so, and now that demo effect, and that isn't to say that the only value is the demo. That's not what I mean, because certainly, helping a customer service agent on a chat, giving them a candidate paragraph of what they can then manually review and potentially paste into the chat window with the customer, things like that can have a real material impact on productivity. And people are starting to measure that now. We're seeing that. That's great. So I'm not here to slam Gen AI. I'm simply here to say, hey, we need to temper the expectation management, which is very poor at this point. But the expectations are actually going to continue to be disproportionate because there's going to be new demos, and there's going to be generated video. There's going to be all combinations. There's so much data that we've generated as humans in our behavior by writing and filming videos and all this kind of stuff, and so you can't reverse engineer the human mind just based on what we've written, as much as you can create astonishing results. But you can do some really amazing results, and the same will apply with video and the combination between the two. So we're going to continue to see things that blow our socks off and are then leveraged to sort of tell the AGI narrative and continue the hype. So it's going to take a while but then at the same time, in parallel, people within the clear machine learning universe where they're actually deploying it at a large or medium-sized organization to improve operations in a concrete way, that's where we have this issue of, hey, it's not deploying as much as it could and should, and let's look at this very clearly. I think that's where there's going to be a reckoning. So even if the broader world's continuing to ride the hype wave, the sort of inner world's going to go through some disillusionment and a correction. And I'm hoping that BizML will be there to help with that.
That is awesome, Eric. Eric, as we wrap up today's episode, do you have any final call to action or note to share with the audience?
Well, go to bizml.com. If you're interested in the book, I hope you find it valuable. And I hope that it, like my first book, it gets included with a bunch of university. If you're a professor, I'm sure that we can get you an evaluation copy. Because I'd love to see university courses that are covering this. This is the thing that's missing. This is what we need to get machine learning successfully deployed.
Eric, it was great having you on Data Framed.
Great to be here, Adele. Thank you so much.